This is Chapter 12, Book 2 of A Journey in Other Worlds. This LibriVox recording is in the public domain. Recording by Tom Weiss. A Journey in Other Worlds, Book 2, Chapter 12, Hills and Valleys. With the first light, they resumed their journey, and an hour after setting out they sighted, as Cortlandt had predicted, another cloud of vapor. The fall, for such it proved to be, was more beautiful than the other, for though the volume of water was not so great, it fell at one leap, without a break, and at the same tremendous speed, a distance of more than 1,000 feet. The cannon rang with the echoes, while the spray flew in sheets against the smooth, glistening sandstone walls. Instead of coming from a river, as the first fall had, this poured at once from the rocky lip, about 2 miles across, of a lake that was 1,100 feet above the surging mass in the vale below. "It is 1,000 pities," said Bearwarden, "that this cataract has got so near its source, for at the rate these streams must cut, this one in a few hundred years, unless something is done to prevent it, will have worn back to the lake, and then good-bye to the falls, which will become a series of rapids. Perhaps the first effect will be merely to reduce by a few feet the height of the falls, in which case they will remain in practically the same place." About the shores of this lake they saw rhinoceroses, with long, thick wool, and herds of creatures that much resembled buffaloes. "I do not see," said Bearwarden, "why the identical species should not exist here that till recently, in a geological sense, inhabited the earth. The climate and all other conditions are practically the same on both planets, except a trifling difference in weight, to which terrestrials would soon adapt themselves. We know, by spectroscopic analysis, that hydrogen, iron, magnesium, and all our best-known substances exist in the sun and even the stars, while the earth contains everything we have found in meteorites. Then why make an exception of life, instead of supposing that at corresponding periods of development the same living forms inhabit all? It would be assuming the eternal sterilization of the functions of nature to suppose that our earth is the only body that can produce them." "The world of organic life is so much more complex," replied Cortlandt, "than that of the crystal that it requires great continuity. So far we certainly have seen no men, or anything like them, not even so much as a monkey, though I suppose, according to your reasoning, Jupiter has not advanced far enough to produce even that." "Exactly," replied Bearwarden, "for it will require vast periods, and according to my belief, at least half the earth's time of habitability had passed before man appeared. But we see Jupiter is admirably suited for those who have been developed somewhere else, and it would be an awful shame if we allowed it to lie unimproved till it produces appreciative inhabitants of its own, for we find more to admire in 1/2 hour than its entire present population during its lifetime. Yet how magnificent this world is, and how superior in its natural state to ours! The mountainous horns of these crescent-shaped continents protect them, and the ocean they enclose from the cold polar marine currents, and in a measure from the icy winds, while the elevated country on the horns, near the equator, might be a Garden of Eden or ideal resort. To be sure, the continents might support a larger population, if more broken up, notwithstanding the advantage resulting from the comparatively low mountains along the coasts and the useful winds, a greater subdivision of land and water, more great islands connected by isthmuses, and more Mediterraneans joined by straits would be a further advantage to commerce, But with the sources of power at hand, the resistless winds and water power, much increased in effectiveness by their weight, the great tides when several moons are on the same side, or opposite the sun, internal heat near the surface, an abundant coal supply, doubtless already formed and also near the surface, such small alterations could be made very easily, and would serve merely to prevent our becoming rusty. As Jupiter's distance from the sun varies from 506,563 miles at aphelion to only 460,013,000 miles at perihelion, this difference in connection with even the slight inclination of the axis must make a slight change in seasons, but as the inclination is practically nothing, almost the entire change results from the difference in distance. This means that the rise or fall in temperature is general on every degree of latitude, all being warmed simultaneously, more or less, as the planet approaches or departs from the sun. It means also that about the same conditions that Secretary Deepwater suggested as desirable for the earth prevail here, and that Jupiter represents, therefore, about the acme of climate naturally provided. On account of its rapid rotation and vast size, the winds have a tornado strength, but they are nothing at this distance from the sun to what they would be if a planet with its present rate of rotation and size were Venus or even Earth is. In either of these positions, no land life with which we are acquainted could live on the surface, for the slope of the atmospheric isobars, i.e., the lines of equal barometric pressure that produced wind by being tilted through unequal expansion, after which the air, as it were, flows downhill, would be too great. The ascending currents about the equator would also, of course, be vastly strengthened, so that we see a wise dispensation of Providence in placing the large planets, which also rotate so rapidly, at a great distance from the sun, which is the father of all winds, rotation alone, however rapid, being unable to produce them. They found this lake was about 6 times the size of Lake Superior, and that several large and small streams ran into its upper end. These had their sources in smaller lakes that were at slightly higher elevations. Though the air was cool, the sun shone brightly, while the ground was covered with flowers resembling those of the northern climes on earth, of all shapes and lines. Twice a day these sent up their song, and trees were covered with buds, and the birds twittered gaily. The streams murmured and bubbled, and all things reminded the travelers of early morning in spring. "If anything could reconcile me," said Bearwarden, "to exchange my active, utilitarian life for rustic, poetic existence, it would be this place, for it is far more beautiful than anything I have seen on earth. It needs but a Maud Muller and a few cows to complete the picture, since nature gives us a vision of eternal peace and repose." Somehow the mention of Maud Muller, and the delicate and refined flowers whose perfume he inhaled, brought up thoughts that were never far below the surface in Ayrault's mind. "This place is heavenly enough," said he, "to make one wish to live and remain here forever, but to me it would be Hamlet with Hamlet left out." "Ah, poor chap," said Cortlandt, "you are in love, but you are not to be pitied, for though the thrusts at the heart are sharp, they may be the sweetest that mortals know." The following morning they reluctantly left the picturesque shores of Lake Serenity, with their beautiful tints and foliage, and resumed the journey to explore a number of islands in the ocean in the west, which were recorded on their negatives. Ascending to rarefied air, they saw great chains of mountains, which they imagined ran parallel to the coast, rising to considerable altitudes in the east. The tops of all glistened with a mantle of snow in the sunlight, while between the ridges they saw darker and evidently fertile valleys. They passed, moving northwest, over large and small lakes, all evidently part of the same great system, and continued to sweep along for several days, with a beautiful panorama, as varying as a kaleidoscope, spread beneath their eyes. They observed that the character of the country gradually changed. The symmetrically rounded mountains and hills began to show angles, while great slabs of rock were split from the faces. The sides also became less vertical, and there was an accumulation of detrital fragments about their bases. These heaps of fractured stone had in some cases begun to disintegrate and form soil, on which there was a scant growth of vegetation, but the sides and summits, whose jaggedness increased with their height, were absolutely bare. "Here," said Cortlandt, "we have unmistakable evidence of frost and ice action. The next interesting question is, how recently has denudation occurred? The absence of plant life at the exposed places," he continued, as if lecturing to a class, "can be accounted for here, as nearer the equator, by the violence of the wind, but I greatly doubt whether water will now freeze in this latitude at any season of the year, for even should the northern hemisphere's very insignificant winter coincide with the planet's aphelion, the necessary drop from the present temperature would be too great to be at all probable. If, then, it is granted that ice does not form here now, notwithstanding the fact that it has done so, the most plausible conclusion is that the inclination of Jupiter's axis is automatically changing, as we know the earth's has often done. There being nothing incompatible in this view with the evidence at hand, we can safely assume it correct for the time being at least. When farther south, you remember, we found no trace of ice action, notwithstanding the comparative slowness with which we decided that the ridges in the crust had been upheaved on account of the resisting power of gravity, and, as I see now, also on account of Jupiter's great mass, which must prevent its losing its heat anything like as fast as the earth has, in which I think, also, we have the explanation of the comparatively low elevation of the mountains that we found we could not account for by the power of gravitation alone. From the fact that the exposed surface farther south must be old, on account of the slow upheaval and the slight wear to which it is exposed, about the only wearing agent being the wind, which would be powerless to erase ice scratches, especially since, on account of gravity's power, it cannot, like our desert winds, carry much sand, which, as we know, has cut away the base of the Sphinx. I think it is logical to conclude that though Jupiter's axis is changing naturally as the earth's has been, it has never varied as much as 23½ degrees, and certainly to nothing like the extent to which we see Venus and Uranus tilted today. "I follow you," said Bearwarden, "and do not see how we could arrive at anything else. From Jupiter's low specific gravity, weighing but little more than an equal bulk of water, I should say the interior must be very hot, or else is composed of light material, for the crust surface, or the part we see, is evidently about as dense as what we have on earth. These things have puzzled me a good deal, and I have been wondering if Jupiter may not have been formed before the earth and the smaller planets." "The discrepancies between even the best authorities," replied Cortlandt, "show that as yet but little has been discovered from the earth concerning Jupiter's real condition. The two theories that try to account for its genesis are the ring theory and the nebulous. We know that the sun is constantly emitting vast volumes of heat and light, and that with the exception of the heat resulting from the impact of falling meteors, it receives none from outside, the principal source being the tremendous friction and pressure between the cooling and shrinking strata within the great mass of the sun itself. A seeming paradox therefore comes in here, which must be considered. If the sun were composed entirely of gas, it would for a time continue to grow hotter. But the sun is incessantly radiating light and heat, and consequently becoming smaller. Therefore, the farther back we go, the hotter we find the sun, and also the larger, till, instead of having a diameter of 880,000 miles, it filled the space now occupied by the entire solar system. Here is where the two theories start. According to the first, the revolving nebulous mass threw off a ring that became the planet Neptune, afterwards another that contained the material for Uranus, and so on, the lightest substance in the sun being thrown off first, by which they accounted for the lightness of the four great planets, and finally Mars, the Earth, and the small dense planets near the sun. The advocates of this theory pointed to Saturn's rings as an illustration of the birth of a planet, or rather, in that case, a satellite. According to this, the major planets have had a far longer separate existence than the minor, which would account for their being so advanced, notwithstanding their size. This theory may again come into general acceptance, but for the present it has been discredited by the nebulous. According to this second theory, at the time the sun filled all the space inside of Neptune's orbit, or extended even further, several centers of condensation were formed within the nebulous gaseous mass. The greatest center became the sun, and the others, large and small, the planets, which, as a result of the spiral motion of the whole, such as is now going on before our eyes in the great nebulae of 51 M Canuum Venaticorum, and many others, began to revolve about the greatest central body of gas. As the separate masses cooled, they shrank, and their surfaces, or extreme edges, which at first were contiguous, began to recede, which recession is still going on with some rapidity on the part of the sun, for we may be sure its diameter diminishes as its density increases. According to either theory, as I see it, the major planets, on account of their distance from the central mass, have had longer separate existences than the minor, and are therefore more advanced than they would be had all been formed at the same time. This theory explains the practical uniformity in the chemical composition of all members of this system, by assuming that they were all once a part of the same body, and you may say brothers and sisters of the sun, instead of its offspring. It also makes size the only factor determining temperature and density, but of course modified by age, since otherwise Jupiter would have had a far less developed crust than that with which we find it. I have always considered the period from the molten condition to that with a crust as comparatively short, which stands to reason, for radiation has then no check, and the period from the formation of the crust, which acts as a blanket, to the death of a planet as very long. I have not found this view clearly set forth in any of the books I have read, but it seems to me the simplest and most natural explanation. Now, granted that the solar system was once a nebula, on which I think everyone will agree, the same forces that changed it into a system of sun and planets must be at work on 51 M Canuum Venaticorum, Andromeda, and 99 M Virginis, and must inevitably change them to suns, each with doubtless a system of planets. If then the condition of a nebula or star depends simply on its size, it is reasonable to suppose that Andromeda, Sirius, and all the vast bodies we see were created at the same time as our system, which involves the necessity of one general and simultaneous creation day. But as Sirius, with its diameter of 12 million miles, must be larger than some of the nebula will be when equally condensed, We must suppose rather that nebula are forming and coming into the condition of bright and dead stars, much as apples or pears on a fruit tree are constantly growing and developing, so that the mosaic description of the creation would probably apply in point of time only to our system, or perhaps to our globe, though the rest will doubtless pass through precisely the same stages. This, I think, I will publish on our return, as the Cortlandt astronomical doctrine, as the most rational I have seen devised, and one that I think we may safely believe, until perhaps, through increased knowledge, it can be disproved. After they crossed a line of hills that ran at right angles to their course, they found the country more rolling. All streams and watercourses flowed in their direction, while their aneroid showed them that they were gradually descending. When they were moving along near the surface of the ground, a delicious and refined perfume exhaled by the blue and white flowers that had been growing smaller as they journeyed northward frequently reached their nostrils. To Cortlandt and Bearwarden it was merely the scent of a flower, but to Ayrault it recalled mental pictures of Sylvia wearing violets and lilies that he had given her. He knew that the greatest telescopes on earth could not reveal the Callisto moving about in Jupiter's sunshine, as even a point of light, at that distance, and notwithstanding Cortlandt's learning and Bearwarden's joviality, he felt at times extremely lonely. They swept along steadily for 50 hours, having bright sunny days and beautifully moonlit nights. They passed over finely rounded hills and valleys and well-watered plains. As they approached the ocean and its level, the temperature rose, and there was more moisture in the air. The plants and flowers also increased in size, again resembling somewhat the large species they had seen near the equator. "This would be the place to live," said Bearwarden, looking at iron mountains, silver, copper, and lead formations, primeval forests, rich prairies, and regions evidently underlaid with coal and petroleum, not to mention huge beds of aluminum, clay, and other natural resources that made his materialistic mouth water. It would be joy and delight to develop industries here, with no snow avalanches to clog your railroads, or icy blizzards to paralyze work, nor weather that blights you with sunstrokes and fevers. On our return to the earth, we must organize a company to run regular interplanetary lines. We could start on this globe all that is best on our own. Think what boundless possibilities may be before the human race on this planet, which, on account of its vast size, will be in its prime when our insignificant earth is cold and dead, and no longer capable of supporting life. Think also of the indescribable blessing to the congested communities of Europe and America to find an unlimited outlet here. Mars is already past its prime, and Venus scarcely habitable, but in Jupiter we have a new promised land, compared with which our earth is a pygmy, or but little more than microscopic. "I see," said Ayrault, "that the possibilities here have no limit, but I do not see how you can compare it to the promised land, since till we undertook this journey no one had even thought of Jupiter as a habitable place." "I trace the divine promise," replied Bearwarden, "in what you describe to us on earth as man's innate longing and desire to rise, and in the fact that the Almighty has given the race unbounded expansiveness in a very limited space. This would look to me as the return of man to the Garden of Eden through intellectual development, for here every man could sit under his own vine and fig tree." "It seems to me," said Cortlandt, "that no paradise or heaven described in anything but the Bible compares with this. According to Virgil's description, The joys on the banks of the river Lethe must have been most sad and dreary, the general idleness and monotony apparently being broken only by wrestling matches between the children, while the rest strolled about with laurel wreaths or rested in the shade. The pilot Palinurus, who had been drowned by falling overboard while asleep, but who before that had presumably done his duty, did not seem especially happy, while the harsh, resentful disposition evidently remained unsoftened, for Dido became like a cliff of Marpesian marble when Aeneas asked to be forgiven, though he had doubtless considered himself in duty bound to leave her, having been twice commanded to do so by Mercury, the messenger of Jove. She, like the rest, seems to have had no occupation, while the consciences of few appear to have been sufficiently clear to enable them to enjoy the unbroken rest. The idleness in the spirit land of all profane writers, added Bearwarden, has often surprised me too, though I have always recommended a certain amount of recreation for my staff, in fact, more than I have generally had myself. An excess of it becomes a bore. I think that all real progress comes through thorough work. Why should we assume that progress ceases at death? I believe in the verse that says, "We learn here on earth those things, the knowledge of which is perfected in heaven." According to that, said Cortlandt, you will some day be setting the axis of heaven right, for in order to do work there must be work to be done, a necessary corollary to which is that heaven is still imperfect. No, said Bearwarden, bristling up at the way Cortlandt sometimes received his speeches, it means simply that its development, though perfect so far as it goes, may not be finished, and that we may be the means, as on earth, of helping it along. The conditions constituting heaven, said Ayrault, may be as fixed as the laws of nature, though the products of those conditions might, it seems to me, still be forming and subject to modification thereby. The reductio ad absurdum would, of course, apply if we supposed the work of creation absolutely finished. This is the end of Chapter 12 in Book 2 of A Journey in Other Worlds. Recording by Tom Weiss.